College Algebra, Module 5, Topic 5.1, Quadratic Functions and Models. Recall that linear functions have points that lie on a line or nearly on a line, and linear functions look like f of x equals ax plus b. A linear function that has a equals 0 is called a constant function. Now remember that sometimes we see these as mx plus b, so the same thing. If m equals 0 or the slope is 0, that's what makes it a constant function. And in that case, f of x is equal to b. If the data is not linear, it could be a quadratic function or some other type of function. As a definition, let a, b, and c be real numbers with a not equal to 0. A function represented by f of x equals ax squared plus bx plus c is a quadratic function. Notice that you have an x squared term. That's what makes it the quadratic when the x squared is the highest power. The term ax squared is called the leading term, and a, the number in front of the x squared, is called the leading coefficient. The domain of a quadratic function is all real numbers. The degree of a quadratic function is always 2. Remember that the degree is the highest power of your variable term. Objective 1. Identifying quadratic functions. We want to identify f as being linear, quadratic, or neither. Now remember, linear means the highest power of the variable is 1. Quadratic means that the highest power of the variable is a 2. So for the first one, f of x equals 8 over 5x squared plus 3, we have an x squared term, but it's in the denominator. Therefore, that is not linear, and it's not quadratic. The second one, f of x equals 6 minus x plus 5x squared, because the highest power is x squared, this one is quadratic. The third one, f of x equals 3x minus 8 over 5. I know that doesn't look like linear, but because the denominator is one term, we could also rewrite that as 3/5 x minus 8/5, which means this is a linear function with a slope of 3/5 and a y-intercept of negative 8/5. And the last one, f of x equals 6x to the third plus 2x squared minus 7x minus 9. Now even though it has an x term and an x squared term, those are not the highest power. This one has the highest power of 3, so that is of degree 3, so that is a neither. It's not linear and it's not quadratic. Objective 2. Parabolas. The graph of a quadratic function is a parabola. I know it looks like parabola, but it is a parabola. And that is a U-shaped graph that opens either upward or downward. In this first one, the graph is opening upward. And in the second one, we say that this graph, or this parabola, is opening downward. A parabola opens upward if a is positive, and it opens downward if a is negative. Now remember, for a quadratic, a is the number in front of the squared term. So if we have a positive x squared term, then it opens upward. If we have a negative squared term, then the parabola opens downward. The highest point on a parabola that opens downward and the lowest point on a parabola that opens upward is called the vertex. this parabola opens upward, so the lowest point is the vertex. This parabola opens downward, therefore the highest point is called the vertex. The leading coefficient a controls the width of the parabola. Larger values of the absolute value of a result in a narrower parabola, and smaller values of a result in a wider parabola. So basically, the larger or the further away from zero that a gets, the more narrow the parabola will be, and the closer a gets to zero, the wider the parabola gets. For example, in the first picture, y equals x squared is the blue line. Notice as we do y equals 2x squared, the graph becomes a little more steep. Or y equals 1/2 x squared, the graph starts to flatten out a little bit. Same thing for the second picture. The y equals negative x squared is the blue line. Y equals negative 3x squared, that's steeper than the blue line. And y equals negative 1/3 x squared, that's your red line. Let's do an example. Use the graph of the quadratic function shown to determine the sign of the leading coefficient, its vertex, and the equation of the axis of symmetry. Well, because the parabola is opening downward, we know that the leading coefficient is negative. So we're going to write a is less than 0, which means that a is a negative number. The vertex, well, the highest point of that parabola is the ordered pair 1, 3. Now, the axis of symmetry, we've not talked about that yet, but that is the vertical line that passes through the vertex. So notice on this picture, the vertex is at x equals 1, so the axis of symmetry is the vertical line that passes through x equals 1. Now what symmetry means is whatever happens on one side of this axis happens on the other side. So look at this point right here. If we look right here, notice that the graph is a little over halfway here and a little over halfway here. Let's go down to where x is 1. Notice it's a little over 1 away here and a little over 1 away on the other side. To write the axis of symmetry, a vertical line always has an x equal equation. So in this case, we're going to say x is equal to 1. As I just mentioned, the vertical line passing through the vertex is called the axis of symmetry. The axis of symmetry will always look like x is equal to a number, and that number is going to be the x value of the vertex. The axis of symmetry of the quadratic function f of x equals ax squared plus bx plus c is x equals negative b over 2a, where the vertex is the ordered pair where the x value is negative b over 2a and the y value is f of negative b over 2a, which basically means you plug your x value back into your function and that will give you the y value of the vertex. Let's do an example of this. Find the vertex of the function f of x equals 2x squared minus 2x plus 1. Well, the x value is found by doing negative b over 2a. So when we look at our function, a is the number in front of the x squared term, b is the number in front of the x term, which in this case is negative 2, and c is the number that does not have a variable, so in this case c is 1. So to find our x value, it's negative b, or the negative of negative 2, divided by 2a, which would be 2 times 2. So the negative of negative 2 would be 2. 2 times 2 in the denominator is 4. So the x value of the vertex is 1/2. Now to find the y value of the vertex, we're going to take 1/2 and plug it back into the function, which we call f of 1/2. So that would be 2 times 1/2 squared minus 2 times 1/2 plus 1. So using the order of operations, we're going to do exponents first. So that would be 2 times 1/4 minus 2 times 1/2 plus 1. Well, is 2 over 4, which is 1/2, minus 2 times 1/2 is just 1, and then plus 1. Well, 1/2 minus 1 plus 1 is going to just give us 1/2. So our vertex is x is 1/2 and y is 1/2. Let's do another one. Find the vertex of the function f of x equals negative 4x squared plus 16x plus 9. Then we're going to sketch the graph. To find the vertex, we're going to use the formula negative b over 2a for x. Well, let's go back to our problem. A is negative 4 because it's the number in front of the x squared term. B is the number in front of the x term, which is 16, and C is 9. So back to our formula, it's negative b, or negative of 16, divided by 2a, which would be divided by 2 times negative 4. So in the numerator we get negative 16, in the denominator we get negative 8, so negative 16 divided by negative 8 is 2. To find the y value, we're going to substitute 2 back into our function, which we would call f of 2. So that would give us negative 4 times 2 squared plus 16 times 2 plus 9. So that would give us negative 4 times 4 plus 32 plus 9. So we would get negative 16 plus 32 plus 9. Well, negative 16 plus 32 is 16. So we get 16 plus 9, which is 25, which says that our vertex is x is 2, y is 25. Let's do it again, but this time let's use our calculator to check this. So what we're going to do is we're going to go into our calculator. We're going to go to y equals, and we are going to enter this function in as y1. So we're going to go y equals negative 4x to the second power plus 16x plus 9. And we're going to graph that. Well, when we press graph, we're going to get something that looks like that. It's not quite looking like a parabola, but we know it could. I'm going to go into window, and because I know that I need my x graph a little higher, I'm going to change my y max to maybe 30 and press graph again. And if you'll notice, now we get a nice parabola. So we want to find the vertex on our calculator. Well, remember we said if it's the highest point, then we call it the maximum. So the way we're going to calculate the maximum is we are going to go second trace, which is calculate, and we want to calculate number 4, the maximum. So when we press number 4, now it's going to ask us to give some boundaries. Well, the first thing is the left bound. So what you want to do is make sure that your cursor is to the left of the highest point. When it is, you press enter. Now it's asking for the right bound. So we are going to arrow over and make sure we're somewhere to the right of that highest point. So we're going to select enter. Now it's going to ask us for the guess. Well, Because our highest point is somewhere between these two arrows, we don't have to guess. So we're just going to press enter one more time. And that tells us that our maximum value is the ordered pair 2, 25, which is what we got earlier. So if we're going to do this on our paper, we would draw our axis over 2, up 25, and we know the parabola is upside down, so it's going to be the upside down U. Okay, you can also use the vertex form of a quadratic equation to find the vertex. If the quadratic equation is of the form f of x equals a times x minus h squared plus k, then the vertex is at hk. Okay, let's just go back for just a second. If we have a formula of the form ax squared plus bx plus c, then to find the vertex, we're going to use x equals negative b over 2a, and then we're going to plug in that number to find the y value. This is a different one. This is if they give it to us of the form a times x minus h squared plus k, then we can just eyeball it. Now, if this factor is x minus h, then the x value is h. Then whatever the number at the end is, that is what k is going to be. Okay, let's do an example of this. Find the vertex of the following. F of x equals 5 times x minus 3 squared plus 4. Because this is of the vertex form, the x value of the vertex is the opposite of this number, which is 3. The y value is the number that's on the end, which is 4. So our vertex would be 3, 4. Find the vertex and then sketch the graph of the following. Well, if our function is f of x equals negative x plus 5 squared minus 6, this is our vertex form. So, we take the number or the expression that's inside the parentheses, x plus 5, so our x value of the vertex would be negative 5. And then our y value of the vertex is the number that's on the outside, which would be minus 6. Now remember, we talked about the leading coefficient, what's out in front of the x term. The leading coefficient is negative, so our parabola is going to open downward. So when we graph that, we've got negative 5, negative 6. So our vertex would be right there. Because it's a negative x squared, we know it's opening downward, so our sketch of our graph would look something like that right there. Objective 4, Applications. A junior horticulture class decides to enclose a rectangular garden using a side of the greenhouse as one side of the rectangle. If the class has 32 feet of fence, find the dimension of the rectangle that will give the maximum area for the garden. Well, remember, if we only have 32 feet of fencing, that is perimeter. And normally perimeter is 2L plus 2W. Well, in this case, we don't need this length right here because we're going to use the barn. So our formula for our example is going to be length plus 2W. Well, because we only have 32 feet of fencing, we are going to use the formula 32 equals L plus 2W. Now remember that. We're going to carry this over to the next page. Okay, we're trying to find the length and width of the rectangle, or of the garden, that would give us a maximum area. Well, area is length times the width. So now we've got two formulas, area equals length times width, and this perimeter formula, but we need to get it down to one formula with one variable. So what we're going to do is we're going to take this perimeter formula, Let's go ahead and solve that to get L on the side by itself, which means we're going to subtract 2W from both sides. If we do that, we get L equals 32 minus 2W. Now we're going to take that and we're going to plug it right back into this area formula. Because we're trying to find the maximum area, that tells us that we want to work with the area formula. So we would get length, which we said was 32 minus 2W times W. Well, if we distribute that, we get 32W minus 2W squared. Well, that's our maximum area formula. Notice it's quadratic because it's a W squared and then a W and then a number. Also, we can look at this and know that the leading coefficient, which is the A in front of the highest power, is a negative. So what we've got is our picture looks like this for our area. Well, the maximum area is going to be right up here at the top. That is the vertex. So we want to find the vertex of this area equation. So we say A is the number in front of the square term, which would be negative 2. B is the number in front of the W term, which would be 32. And C, there's not another number out there, so C is 0. So to find the vertex, we're going to do negative B divided by 2A, which is negative 32 divided by 2 times negative 2, which is negative 32 divided by negative 4. So our x value of our vertex would be 8. Now the y value of our vertex means we're going to plug it back into our area formula. So the y value would be 32 times 8 minus 2 times 8 squared, which would be 256 minus 2 times 64, which would be 256 minus 128. So the y value would be 128. So our x, which in this case was really W, so our W is going to be 8. That's our width. Our length, well, we said our length is 32 minus 2 times 8, which would be 32 minus 16. So our length would be 16. So the dimensions of our rectangle would be a length of 16 and a width of 8. Well, let's just check it for a second. If we had a length of 16 and 2 widths of 8, would that use all 32 feet of our fencing? Yes, it would. 8 plus 16 plus 8 is 32. What would the area be of our maximum garden? The area is the length times the width, which in this case would be 16 times 8, which would give us 128 for a maximum area. Let's do another example. A model rocket is launched with an initial velocity of v sub 0 equals 150 feet per second and leaves the platform with an initial height of h sub 0 equals 10 feet. Its height after t seconds is given by the function h of t equals negative 16t squared plus 150t plus 10. How high is the rocket after 3 seconds? Well, here's our height formula for any number of t seconds. So if they are asking for the height after 3, we are simply going to go into our formula, negative 16 times 3 squared plus 150 times 3 plus 10. Well, using our calculator, we are going to get negative 16 times 3 squared plus 150 times 3 plus 10, which gives us a height of 316 feet. Then the next question says, find the maximum height of the rocket. Well, same thing. We look back at our function. It's a t squared, which means it's quadratic, which means it's a parabola. The leading coefficient is -16, which means it's going to open downward. So the maximum height is going to be at the vertex. So to find the vertex, we're going to do x equals -b divided by 2a. So for our problem, a is -16, b is 150, and c is 10. So we would get -150 divided by 2 times -16, which is -150 divided by -32. -150 divided by -32, so our x value of our vertex is 4.6875. That is the time that it's going to reach its maximum height. The maximum height is really the y value. So to plug our y value back in, we're going to do -16 times 4.6875 squared plus 150 times 4.6875 plus 10. So let's plug that in our calculator, which would give us a maximum height of 361.5625 feet, or about 362 feet. Now we could check it on our calculator. Let's enter our equation, -16x squared plus 150x plus 10. If we graph that, now remember we've got a maximum height of 362 feet, so what we probably want to do is go into our window. We're okay to do -10 to 10 for our x values, but we probably want to change our y's to maybe from -10 to 400. When we graph that, there's our parabola. We want to find the vertex, which is the maximum value. So we are going to do second trace, which is calculate. Number 4 is the maximum. Now notice our cursor was down here at 0, so we're going to say enter for a point to the left. We're going to cross over the highest point. Anywhere on that right side is fine. And then we're going to hit enter for guess. And that tells us that our maximum value, x, is 4.6875. And our y value is almost 362, which is what we got pencil paper method. Next example, the height s of a baseball in feet after t seconds is given by the function s of t equals -16t squared plus 96t plus 2. What is the height of the baseball after 1 second? To find the height, we plug the number of seconds in, which in this case would be 1. So s of 1 equals -16 times 1 squared plus 96 times 1 plus 2, which would give us -16 plus 96 plus 2, which would give us 82 feet. The second part says, find the maximum height of the baseball. Well, again, here's our function. It's a t squared, which means it's a parabola. It's a -t squared, which means it's opening downward, which means it looks like this. The maximum height is going to be up here at the vertex. So to find the vertex x value, we're going to do -b divided by 2a. So a is the number in front of the square term, which is -16. b is the number in front of the t, which is 96, and c is 2. So when we plug it in, we get -96 divided by 2a, which would be 2 times -16, which is 3. Now remember, that's not the maximum height. That's the time that it takes to reach the maximum height. So to find the maximum height, we're going to substitute it back in to our maximum height formula. So we would get S sub 3 equals negative 16 times 3 squared plus 96 times 3 plus 2, which would give us negative 16 times 9 plus 288 plus 2. Okay, again, let's pull out our calculator. So we would get negative 16 times 9 plus 96 times 3 plus 2, which would give us a maximum height of 146 feet. And then C part says, how long does it take the baseball to reach its maximum height? Well, that is the x value of the vertex, which we said earlier was 3, so it would take 3 seconds in order to reach the maximum height. Okay, again, we can do this pencil paper, or we could have just punched it into our calculator. Negative 16x squared plus 96x plus 2. I'm going to go back to Zoom 6 just to square us up. Doesn't look like a parabola. We know it's a parabola because it's a t squared. So let's go into window. Let's change our window. This time I'm just going to go to Zoom 0, which is a zoom fit, and see what it gives us. Notice when we do a Zoom 0, we get a parabola. It doesn't look real pretty, but we get a parabola. What we're trying to get is this vertex up here. So we've got enough to see it. So we're going to go second trace, which is calculate. Number 4 is the maximum. Left bound, we're already to the left of the highest point, so we're going to press enter. Right bound, we're going to arrow over. We're going to make sure that we cross the highest point. Press enter once we get over there. There is no guess, which says that the maximum is 3,146, which is what we got when we did it pencil paper. The 3 seconds to reach the maximum height, and the maximum height was 146 feet. Okay, another application. Suppose the revenue R in hundreds of dollars that a company receives from producing X hundred cell phones is given by the formula R of X equals X times 16 minus 3X. Evaluate R of 3 and interpret the results. Well, R is the revenue and X is the number of hundred cell phones. So R of 3, when we plug that in there, would be 3 times 16 minus 3 times 3, which is 3 times 16 minus 9, which is 3 times 7, which is 21. So R of 3 means the revenue from producing 300 cell phones is $2,100 because R is the revenue in hundreds. B part says, how many cell phones should the company produce to maximize its revenue? Well, remember, your revenue is X times 16 minus 3X. If we distribute that, we would get R of X is equal to 16X minus 3X squared. Again, notice, it's an X squared, so we know it's a parabola. The leading coefficient is a negative 3, which means our picture looks like this. If we're looking to find where it maximizes the revenue, we're looking for the vertex. So to find the vertex, the X value is negative B over 2A. So for our problem, A is the number in front of the square term, which would be negative 3. B is the number in front of the X term, which is just 16. There is no number term, so C is 0. So when we substitute it in, we get negative 16 divided by 2 times negative 3, which would be negative 16 divided by negative 6, which would reduce to give us 8/3. So how many cell phones should the company produce? Well, let's get 8/3 as a decimal. So 8 divided by 3 is 2.67. This should be in hundreds, so let's say we said times 100, which would give us 267 cell phones to get a maximum value. Okay, so when they ask us for the maximum revenue, remember, we're going to use the 8/3 for X, not the 267 cell phones, but we're going to use the actual X equals 8/3. So the revenue for X equals 8/3 is, going back to our revenue formula, 16 times 8/3 minus 3 times 8/3 squared, which gives us 21.33 for our revenue. Remember, this is in hundreds of dollars, so if we multiply that by 100, we would get $2,133.33 for selling 267 cell phones. Now for Objective 5, regression, finding the best fit for a quadratic function. Remember, we used the least squares regression to find the line of best fit back when we did linear functions. So now we're going to use the least squares regression to find a quadratic function that models the data given in the table. To do this on our calculator, we're going to go to Stat, we are going to Edit, and we are going to enter the X values in as L1, so we would have 0, 2, 4, 6, 6, and 8. For our Y's, our L2's, we're going to have 200, 150, 110, 90, and 80. Now this time when we go to Stat and we go to Calc, instead of doing option number 4 like we did for linear, we are going to go down to option number 5, which is quadratic regression. Press enter, and that gives us our data. So we get y equals a is the number in front of x squared, which would be 1.79 x squared, plus b, well, b is a negative, so I'm just going to call it minus 29.29 x, plus c, which was 200.29. So this is our graph that best fits the points that they give us in our picture. Now let's check this just to make sure. Do you remember how we did stat plots? We're going to go to second stat plot. We're going to do number 1 to turn it on, hit enter to turn it on, and then we're going to go to zoom stat, which finds us a window in which all of our points will fit. So when we do graph, so we're going to do zoom. Now remember, we could change our windows, or we could just go zoom 9. If we go zoom 9, that gets us a window that fits all of the points that we just put in our stat window. So there's our picture. Notice it sort of looks quadratic. So now we could go back into our y equals, and we could enter this equation. 1.79 x squared minus 29.29 x plus 200.29. Now when we hit graph, notice our line of best fit, or our regression line, comes pretty close to all of those data points. Okay, last example. The table below lists the amount of emissions of a certain pollutant in millions of tons. It gives us the year, and it gives us the emissions of a certain pollutant. If the amount of emissions is modeled by a quadratic function where x is the number of years since 1980, estimate the amount of emissions in the year 2040. Now this is very important. When we go to set up our data, we don't want to use the x of the years that they give us. We want to use x to where x is the number of years since 1980. So when we go to do our table, this one's going to be 0. 1985 is 5 years since 1980. 1990 is 10 years since 1980. And 1995 is 15 years since 1980. Now if you're doing this on your calculator, remember you need to clear out your list, so you would just put your cursor up on L1, press clear, press enter, and that clears your list out. So when we start, we're going to have in L1 the x values of 0, 5, 10, and 15. Enter the y values. So once we get our y values in there, we're going to go Stat, Calculate. We want the quadratic regression number 5. Press enter, and that gives us our quadratic regression equation. So for part 1, we get y equals negative 0.008 x squared plus 0.8x plus 18.8. Now for the second part, it says find the amount of emissions in the year 2040. Well, our first question is how many years since 1980 is 2040? Well, if you subtract that, then we would get 60 years difference. So we are going to go into our formula and plug in x is 60. So we get y equals negative 0.008 times 60 squared plus 0.8 times 60 plus 18.8. So when we enter that into our calculator, we get y as 38, which means in the year 2040, the pollutant emissions would be 38 million tons of emissions. You are now ready to do the homework for Module 5, Topic 5.1 in My Math Lab.